In today's digital world, teachers commonly transfer digital creation skills to communication skills to enhance how they communicate to parents and with each other and with other members of the community. And yet in teacher education, we make the assumption that just because they are digital natives, that they know how to use digital technologies to communicate and to communicate effectively. Research in this field is showing a different story. And since Prensky's idea on digital natives is about 20 years old, it requires a new look as new technologies are changing the way we communicate in today's digital world. In science education, the role of videos has been a strong method of communication, as evident by the work of Hoban and Wang. We now know that from current research that video-based learning is built upon Mayer's multimedia theory of learning, which values the communication skills that lower the burden of cognitive load for a diverse range of students. I have been using videos to enhance my teaching for the past 12 years and have taught others to make videos to enhance their teaching for many of these years. And this led me to the question of how we, as teacher educators, can model quality videos, provide explicit teaching skills around how to create videos, and then be certain that their videos are being assessed through their different topics. This gap, assuming that students could learn how to communicate effectively through videos, was explored early this year by developing and teaching a group of science education students to make a direct connection between the purpose of working scientifically and how they learnt in their science topic. I created the project called Timna Teaches to help share this particular journey. I wanted to work alongside my students to learn how to make not only quality videos, but that could directly be used in the current content creation strategies that we know enhance and impact viewers. Together, I wanted to explore what they did and compare what I did, showing them that working scientifically through video was part of the way we communicate and extend beyond the classroom. With this transferability in mind, we wanted to really focus thinking about their future career as teachers. The solution, as I saw it, was threefold. I enrolled in short courses that focused on learning what skills were necessary for video creation, using tools like Instagram, YouTube, and TikTok. I then adapted their learnings from their point of view in the arts to science curriculum topics where we already used a digital portfolio to work scientifically. But I provided the students with opportunities to film their experiments each week and report their findings using their journal and their social media platform. I created a short course that I delivered weekly components in class to help target the skills that I had learnt in my short courses, and its success was assessed through the students who opted to use social media and shared this through their workbook. The topic I chose to test this idea was thinking and working scientifically in the early years. I created a context for my pre-service teachers in the 4th year of their studies. I made changes to how I explicitly taught digital media skills to support their success, and I provided this instruction not only within Flow but as mini workshops during the topic. As shown here, these resources were provided as a way to enhance them about the broad skills that they will require around making videos to communicate effectively. And by focusing on a weekly component within the workshop, I was dedicating some of their learning from the content creating strategies that I had learnt during my initial training. I positioned this investigation around how science curriculum skills rely on similar communication strategies using social media tools. To visualise this process from start to finish, the experiment was provided for each week and the students encouraged to film this particular experiment. I provided a tripod which would encourage the students to elevate how they filmed and how steady their filming was. As we explored concepts such as time lapse and slow motion, this suited some experiments particularly well. In conclusion, I see that this particular project was very successful. The results from the final assessment really do show exactly what the students were capable of doing to help enhance their learning.